Okay, hey guys, this is first problem one I'm gonna do about trig substitution, and this is gonna cover the sign substitution by the equation, and we can tell this by a squared minus x squared, where the 64 is minus the x squared. So when we move on trying to solve this, we do the square root of 64, which is 8, and we put 8 squared minus x squared, and this then the x value will become 8 sine theta. We then write the derivative, and this is going to be to dx 8 cos theta d theta. What we do next now is we substitute it back into the equation, and how we do this is write the integral inside this bracket. It's going to be 8 sine theta squared, and over, I'm going to put this to 8 squared minus 8 sine theta squared, and then this will be times with 8 cos theta d theta within respect to that. Further on, we try to simplify this form, and how this becomes is, this is 8 squared times 8, this becomes 8 cubed times sine theta squared times cos theta over, what we do now is this becomes 8 squared, and this is already 8 squared, so because 8 squared is a common factor, we take it out of the root and it becomes 8, and this becomes 1 minus sine theta squared within respect to d theta. Now I'm going to clear all of these guys, make sure you guys take some notes, and I'm going to rewrite this equation down there so I can continue on simplifying it. So within this, we're gonna write 8 cubed sine theta squared cos theta, and this will be 8 1 minus cos, sorry my bad, 1 minus sine theta squared d theta. Writing this down, this will become 8 squared because 8 cubed divided by 8, this will become 8, this will become sine theta squared cos theta squared, and then this becomes 1 minus sine theta squared. Now guys, I'm just going step by step so you guys just understand where I'm coming from. Now here it kind of looks pretty complicated how it's 1 minus sine squared, but we can make this simple by this rule. And how this works out is, we know that sine theta squared plus cos theta squared is equal to 1, and cos theta squared is equal to 1 minus sine theta squared. And now we sub in the cos squared, and by doing so, cos squared to the square root will just become cos, and writing this down here, this will become sine theta squared cos theta squared over cos theta. Sorry guys, that's my bad, this is not supposed to be squared, sorry guys, and this also is not supposed to be squared. So just originally, if you guys go back, those cancel out within respect to d theta. Okay, now we are left with 8 squared sine theta squared, and what we do now is we need to find the integral for the nature of sine squared. And there is an integral table if you guys go in your textbooks to search it up, but I'm just going to decrease time and go straight forward to this, and I'm going to write it down. And what it is usually something with a sine theta squared. The integral for that would be, sorry guys, I'll just write it at the bottom so because it's pretty long. So this is the sine theta d theta, and this is equal to 1 minus cos 2 theta over 2 d theta to half theta minus 1 over 4, and then sine 2 theta plus c. What we do now is we're going to sub in our own values, and by doing so we're going to write it like this: 64, 1 minus half the angle, which is cos 2 theta over 2 d equals, which in this case is going to be 32, because 64 over 2 theta minus, actually I'm going to make this a little bit less tricky. It will just be 64 over 2, and this will be 64 over 4 sine theta plus c. Now I'm going to rewrite this again over there so you guys can keep it up, and I'm going to just erase all of this just to go on to the next step. Okay, so what we do now is we're gonna write it down, and how we do this is, again, it's gonna be 64 1 minus cos 2 theta over 2 d theta equals 64 over 2 theta minus 64 over 4 sine 2 theta plus c. Okay, and now we need to simplify this. So how we do this is we're going to just worry about this integral, and again, it's just going to be 32, and I'm going to take this out. This will just become 2 over sine 2 theta. Now again, this looks pretty complicated where it is sine 2 theta. Now what we know, we're going to use the double angle identity, which in this case is going to be if sine 2 theta will just equal to sine theta cos theta, and by subbing this back in, because it's an over 2, it's going to cancel out, so it's going to be, so the equation is going to be just nice and simple, and it's just going to be just the same thing. I'm not going to repeat it again. Just sine theta cos theta plus c. Now this, we got the solution, but however it's written in the form where it's in existence of theta. We want to take this back to x. So how do we do this? Alright, so now I'm just gonna, okay, so back again, just rewrite it here, and cos theta plus c. Now we need to write, we know that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and theta is just equal to sine inverse of opposite to hypotenuse. Now, if we draw the triangle, nice right angle triangle, this is hypotenuse, opposite, and adjacent, and this is the angle. Now, what we do is, we know that the hypotenuse is equal to 8, recently, back then, and opposite is just equal to x, and the adjacent is just equal to square root hypotenuse squared minus opposite squared, which in this case will be 64, because 8 squared minus x squared. And we know this because this is 8, this is x, and this is square root of 64 minus x. Now, going back to the sine, cos, and the theta values, sine theta is just equal to x over 8 again, and cos theta is equal to the root, which the value of the adjacent, over 8, and because it's over the hypotenuse, and theta is just nice and easy, just a sine inverse, and again x over 8. Okay, so now we need to sub those back, and how we do this is we just need to rewrite it down. This is the original equation, theta minus sine theta cos theta plus c, and we know that sine theta is equal to x over 8, cos theta is equal to root 64 minus x squared over 8, and theta is just equal to sine inverse x over 8. And by subbing those, we're gonna have it like this, and this is just x over 8 minus x over 8 times 64 minus x squared over 8, sorry guys. And now we simplify this, so by simplifying this is just going to be, when we times it, just 32 sine inverse x, sorry guys, and I forgot the plus c, again another error, sorry guys, and this will just become 8 minus, so when we times this together, the denominator by this is going to be 64, and 32 over 64 will just be half, so that will be just x over 2, and times 64, because we can't change this, by 2 plus c, and there you go guys. This is the solution within respect to x, by finding out the values of through the triangle of theorem. So thank you guys for tuning in, and don't forget to subscribe to my new channel. Sorry guys, very terrible my spelling. Yeah, so don't forget to subscribe to my new channel, MX Mathematics, and I'll be hopefully uploading another video by the end of next week for